Hello. Assuming you all are aware of fundamentals of blockchain, consensus, proof of work, and proof of stake, I'd like to demonstrate my academic project, implementation and simulation of proof of stake consensus protocol in distributed ledger technology. Before diving in, let me give you all a brief about how proof of stake works. It's a six-step procedure where a user stakes some tokens showing their interests to be a validator to mine the next block. The algorithm randomly selects a validator from the pool. The probability of being selected as a validator corresponds to the amount he vested. It's like buying lottery tickets. You buy more, chances to win increases. The next four steps are common as proof of work. Selected validator proposes block, other validators verifies the transactions in the block, and the block is added to the chain, and the validator earns the transaction fee. Behind every crypto transaction you make, all these steps happen. When we use the existing blockchain, it's difficult to simulate and understand the procedure. So we are here breaking down every step for you. Here, the deployed smart contract itself acts as a blockchain. Well, enough of theory. Let's simulate the procedure. We made this single page for every user role, so we need to change the MetaMask accounts accordingly. Now, step 1 is addition of validators. That means people buying lottery tickets. They need to stake some money, in this case Ethereum, to participate in the competition. Let me just change the account to validator 1, and for suppose he stakes 1 Ethereum. We need to sign the transaction in the MetaMask pop-up. Then we can see a confirmation saying validator is added successfully. For making it more clear, we shall add another validator with more stake. Let me change the account to validator 2, and let me add 3 Ethereum for his staking. I need to confirm the transaction in the pop-up, and he is added as validator. We can visualize how many validators are there in this particular pool right now by this graph in this pie chart. So as we can see, validator 1 has vested only 1 Ethereum, so he has got only 25% chance. And the validator 2, as I've added 3 Ethereum, he has got 75% chance of being selected. As the current transaction pool is empty, let me just make some transactions. For making a transaction, let me just change the account to uh, another one. Let's call it transaction caller 1. I just need to add some two address. Let me just take some random address from the Ganachi, and let me just add 2 Ethereum as a transaction. Okay, it was a small technical glitch. So I'm adding a transaction with value 2, and we can see the MetaMask pop up, and we need to confirm. Let me add another transaction to the pool. So basically all these transactions are that transactions that we make. Uh, they're not directly credited to the two address. Let's choose. So here you can see they are not directly credited to the two address because This validation process has to happen as we broke down the steps into one by one. Once the transaction is mined, only then the amount is reflected in the to address. Usually, when we make crypto transaction, all this process happens behind. So yeah, as I've shown, this is the simulation. Uh, so let me just choose a validator. This is the actual step. So this can only be done by admin. So we need to change the address to admin. Again, it goes to smart contract, calls the function, and finally chooses someone as a validator. Well, now the control moves to the selected validator. He can now mine the transactions by clicking mine. We need to change the address to the validator's address, the selected validator's address. So it is ending with F. Maybe as we staked 3 Ethereum from validator 2, he must have the more probability. So I think, yeah, he is the validator. So we can just click on mine, and again the MetaMask pop-up comes. We need to sign this transaction and click on confirm. That's it. So as we can see, block 1 is added to the blockchain. Block 0 is the Genesis block, and block 1 is the one that we added just right now. So it has two transactions from and to address are given here. Now they will be processed. So we can see, yeah, the balance increased. So this is a demonstration of our academic project. Thank you.